My name is Mark Hersam. I'm a professor at Northwestern University. My area of research is nanomaterials. Nanomaterials are materials that have at least one dimension at the nanometer scale, where a nanometer is 1/1000th of a meter. The reason they're important is that they allow a miniaturization to occur. Miniaturization is a driver in many technologies. But more fundamentally, what happens at the nanometer scale is that the properties of matter can be tuned into ranges of properties that are impossible at larger length scales. What our lab does is we go now even smaller, pushing to the ultimate limit down to the size scale of individual atoms and molecules in order to further enhance electronic technology. A carbon nanotube is best thought of if I introduce graphene first. Graphene is a two-dimensional material, a sheet-like material. Graphene has very high charge carrier mobility, which means that you can conduct electricity very quickly. Fast is often what you want in electronics, so graphene is a promising material. A carbon nanotube, on the other hand, is a sheet of graphene rolled up into a cylinder, and you can realize hundreds of different types of carbon nanotubes. Each of those carbon nanotubes has different properties, and so you need to have a high degree of homogeneity in your carbon nanotube population to get reliable and reproducible performance in technology. So the problem becomes one of separation. How do you separate carbon nanotubes where their diameters are varying literally by one atom? We tried to use ideas from physics like the optical properties or electrical properties of the nanotubes. Those proved to be insufficient to solve the problem. And as a result, we began thinking more generally, thinking outside of the bounds of those traditional disciplines, and ultimately realized there were solutions in biochemistry that could solve a problem in the physical sciences. And so our thought was that since biochemists have utilized density gradient ultracentrifugation for similar purposes, that perhaps we could adapt that method to the carbon nanotube separation problem. And we were very happy to find that it worked. Our work, we believe, can benefit society by enabling improved technologies which are used in everyday life. The most direct example is in electronics, making the electronic devices smaller, in the area of batteries to enable vehicles which will elicit less toxic gases into the environment, and even in medical technologies. When I first got the call from MacArthur, initially I thought it was a joke or that this couldn't be correct. I was reassured, and of course I think I still was in shock. Perhaps I'm still in shock. I think upon reflection I've realized that what it provides is freedom. It will allow us to explore the most ambitious projects in the most creative ways without any encumbrances.